Now see a light emitting diode. These are also known as LEDs. You know, light emitting diodes are heavily doped diodes. They are used in forward bias. And what happen in the light emitting diode, if you have got suppose like P and N type semiconductor and this is the junction. When these diodes are in forward bias, you know, electrons are sent to the N to P and holes are sent from P to N. Because of that, concentration of minority carrier increases near the junction. Here it means electrons will be more and here holes will be more. So, due to increase in the concentration of the minority carrier, these minority carrier near the junction start recombining with the majority carriers. And during the recombination of the majority carrier, energy is released in the form of the photons. And if this energy is small, or you can say the forward current is small, this energy is small and may not be in the visible region. So, when these photons are in the visible region, so this one or these diode are made of the such material, they glow at that light here or at that photons. So, we use generally the LEDs of the different colors like red, blue, green, orange, yellow, and for making the LEDs of the different colors we use different materials. So, here this requires very less power, very less energy to recombine or to start. So, these can be used for switching on and switching off the circuits, and also these are the low operational devices or low operational power. So, operational power is very less and no warm up time is required in this case. It is a very spontaneous process. As soon as forward biasing is done, emission of the photons starts. So, this is about the LEDs, and also this is a very low cost and there is no problem of the fusing all these things here. So, basically here the photons which are emitted due to the transparent material, they glow or they give the light if it is they are in the visible region. So, that depends on actually the energy of the photons emitted.